Hello student. Mm, Today we will discuss about the fundamentals of embedded system. An embedded system in robotics consists of number of units. In this unit we will discuss about the fundamentals of embedded system, introduction of embedded system, their application areas of the embedded system, then categories of the embedded system, overview of embedded system and their architecture, specialties of the embedded system like reliability, performance, power consumption, cost, size, limited user interface, and software upgradation capabilities. These subtopics we will discuss under this unit. So, embedded system, an embedded system, is a computer designed to perform a dedicated function within a large mechanical or electrical system. Yeah, we can say that it is a combination of hardware and software. Yeah, we can say that it is a hardware, software, memories, and other specific devices are included in this particular embedded system. It is not a general purpose computer, but rather a specified system, but with hardware and software. For it is designed for the specific task. The embedded system may be the operating system, may not be the operating system. Both type of embedded system we can design. So simple example, we say that type in next slide we have the different types of categories of the embedded system. And then in daily life we are using these type of embedded system which will control, yeah, which will design for the specific task. We'll see the diagram of the embedded system. In this diagram, number of applications are there, like manufacturing equipments, maybe the type of the embedded system, domestic appliances, the types of the embedded system, audio visual equipments, the type of the embedded system, gaming consoles which we are using for the game is the type of embedded system. In telecommunication we are using number of appliances is the type of embedded system. In medical devices in hospital, right now we are using number of devices to measure the different types of disease or tests. So it's the type of embedded system. In automobile industry like car and vehicles, we are using number of devices with their applications, the type of and motion sensor. So number of devices are there. In if we'll discuss about the layered architectures in embedded system, there are three layers are there. Inner layer that means hardware, middle layer operating system, and outer layer will be the outer layer with the any type of application. So without operating system, it's not possible to design embedded. But most some of the cases you can design the without operating system also. And we'll discuss about the simplify architecture, is consist of the any type of processor, input output devices, memories, specific uh, application circuitries, and then communication devices. So these all we can say the make together you can design any application using these of them. Types of the embedded system. So there are three categories are there. So first one is the real-time embedded system. These systems are designed to perform specific tasks within a defined time frame. They can be further divided into two parts. First one, hard real-time. Hard means like a critical deadline is given in this particular embedded system like aircraft control system, there is delay is not allowed in that case. Failure is not allowed. The critical deadline must be the met, and any delay can lead to system failure. Like other type of soft real time. That means deadline is not important, but sometimes flexible. If deadline is there, there is no problem. So minor delay might not be cause any failure. So that means this type of application, the soft real-time embedded systems. So there are two categories are there. So in daily life we are using these type of embedded system. Microwave we are using this is the example of the soft real-time application. In the government they are using aircraft control and defense, these type of real-time embedded systems. Second category is a standalone embedded system, like the name indicates is a standalone. That means we can move, we can use somewhere easily and then portable. So these systems operate independently without needing a host system. For example, including calculator, MP3 players, we can move here and there easily. And then they have their own battery backup and not required any power supply. It's easily you can move system. So this type of embedded system. Okay, next one is the network embedded system means which appliances, this type of appliances we are using, devices we are using for the communication systems and other than networking, like these systems are connected to the network, whether it is wired or wireless, to connect with other devices or systems. For example, home security system or point of sale system. Other devices which we are using like Ethernet card we are using is the type of embedded systems. Others we are using modem we are using that type of embedded system. So these type of other mm, in the telephone exchange we are using other devices switch offs and these other type of embedded system. Next category is a mobile embedded system. These are contact portable system like smartphone, digital camera, laptops. These all are comes under the mobile embedded system. Today we are using the mobile and that it consists of number of devices like transmitter is there, receiver is there, camera is there, and everything is inbuilt. We can take the okay, give the command for the printer also and record download number of devices transmitter we are using to transmit data, we are receiving the data, and then we can connect the other devices also, memory card. So number of devices, so it's a very that real-time data system. You can say the most of the places we are using. So these are the categories. Four categories are there in data system which we are using in our daily life. Facilities of the embedded system, that means number of features, we can say the facilities are there which we'll discuss one by one. So first, a particular embedded system designed to perform the single dedicated function rather than the general purpose. That means it is designed for the specific task. Okay, not general. Next, real-time operating system. That means real-time and embedded systems that then the real-time constants are there, which will follow for the particular real time. So that is important for the real-time operation. Resource constraints, some limitations are there in resource constraint. Within particular resource memory we can design the embedded system. High reliability, that means failure is that embedded system are frequently used in critical application. Your failure is unacceptable. Generally, this type of devices we are using. Therefore, reliability and robustness are the paramount we are required for the testing and other purpose. Next is the size, compact size. You will see the embedded systems required to be the small and lightweighted, along for the integrated into the various devices. So the import compact is the important things which will use in various applications. Let's discuss about the cost sensitivity that embedded systems are often designed with the cost mind, and then as they must be the larger production with the large price. So the cost is the main constraint. Next one, interfacing capabilities. So that means we can interface this type of devices with anywhere. So it is capable to interface with the system and other to communicate the any devices. Software and firmware. Embedded system rely on the specific software or mainframe firmware to execute their design task. This software is often used in specific hardware functionality of the system that ensure efficient and then reliability operations. Hardware component, as I earlier told, that number of hardwares are there, but common hardwares like embedded system includes microprocessor, microcontroller, memories, that means ROM or RAM may be there, input output devices, references, potentiality, specific hardware accelerate for the specific task. So many devices are there which we will use. So low power consumption. Many embedded systems are designed to be the energy efficient, particularly those used in battery powered devices. This low power consumption is achieved through optimized hardware and software design as well as efficient power management techniques. So these type of devices we can use, and then so these are the capabilities. Here we can see the specialization of the specialties of the embedded system which we can. So we'll see the main things as the specific hardwares we require, that is important. Specific task, these type of devices designed for the specific task. And then next we'll see that there is a memory constraint. Limited memories are there for that, according to we need to use that this type of microcontroller and then processors, that is the important. And where we are using the type of devices that is the important. Next, these are other real time, so different types of operating system we are using. So specific task focus real time that we have discussed. Resource constraint already we have discussed about the. Okay, then reliability, can reliable as compared to the, if we'll compare with the microprocessor and the system, so what as it is very reliable. And then in terms of cost also, we can take easily, student can make project their project easily due to the cost using Arduino board and then other microcontroller. If you see the cost of the microcontrollers is 200 300 is easily use that a student can purchase that particular device. So the cost is very important. Sensitivity is that means cost that embed that larger effectiveness software and hardware is there. Like in mobile system, there is a Android operating system which is many places it is being used mobile system. So that is the, already that we have discussed the interfacing capabilities. Anywhere we can enter protocols, we can use sensor actuators, and then other applications like stepper motor, and then DC motor to design any particular applications. So these are the constant which will. So today we will discuss about the architecture type of the embedded system and their facilities of the embedded system. Thank you.